All right, the champs are here. AP Calc, lesson number 18, the chain rule day 2. This goes chain rule level 3. So here, the same idea of the inside and the outside with the red and blue is going to apply, and these will get a little more tricky. So let's look at the first one here. Notice we have y equals 3 sine to the, how do you read that? Sine to the 4x, right? So here, one little trick you're allowed to say is that sine to the 4 of x is equal to sine of x, the whole thing, to the 4. Okay? You're basically just allowed to take this 4 that's over here, and it's like putting parentheses around the whole sign and raising it to the 4. So how can we use that little trick over here? Notice that this is y is equal to 3 times sine of x, the whole thing to the 4. And then how will this help us with the chain rule? Notice that this will be our outside, and here this will be the inside of sine of x. Okay? And using the chain rule, what I want you to do is try and do this without my help, right? Okay, so y is equal to, so this is the setup. This is the outside and this is the inside. Here, dy dx is equal to, okay, take the derivative here. 4 times 3 is 12 sine of x, right? Nothing happens here, and this is to the 3 times, okay, now we got to take the derivative of sine of x. Okay, so what's the derivative of sine of x? So dy dx equals 12 sine of x cubed times cosine of x. Okay, and the idea is this just becomes 12 sine. Now notice that remember how before we were allowed to take the 4 and put it on the outside? Then the same rule applies where you're allowed to take the 4 and put it back on the inside. So notice that this 3 is on the outside. We're just going to put it back on the inside like this times cosine of x. And that's it. And if you want, you don't have to put the parentheses, but I think for now, so you guys get a feel for it, start putting the parentheses, okay? And this is dy dx. And now that we're done, let's put a nice big rectangle over the whole thing. Okay, great job. What I want you to do is try and do number 2 all by yourself, okay? Take your time. Okay, so let's look at number 2. Here, the same idea what we did for number 1, where we pulled out that 4 and put it over here, we're going to do the same thing for the cosine to the 4 of x. So here, this is cosine of 4 of x. That's equal to the cosine of x, the whole thing to the 4. Oh, my bad. So I'll write it again here. It's just this will look like that on the outside. So here we have y equals negative parentheses cosine of x, the whole thing to the 4, right? And then now here we need our outside and our inside. So here this is our outside, which is negative parentheses to the 4, and the inside here will be cosine of x. Okay, now if you feel like you needed help with that first part, try and continue without me if you feel like you got lost. But here now we do the chain rule. So dy dx is equal to negative 4 cosine of x, the whole thing, 4 minus 1 is 3, times the derivative of the inside. So here this is cosine of x, and we're going to take the derivative of that. Okay, so dy dx is equal to negative 4. Notice that we're allowed to put the 3 back in here, so cosine cubed x times the derivative of cosine of x is negative sine of x, right? And then now here we're going to apply the negative, so this negative times this 4, this is positive 4 cosine cubed x times sine of x. Yeah. And this is dy dx. Yep. Okay, not too bad, right? Not too bad. All right, let's try the next one. Same idea, just a little bit different. What is your inside? What is your outside? Let's try and set it up. So y equals this 3 cosine parentheses 2x squared. That's the inside. Okay. Dy dx. What's the derivative? Now remember over here that remember you don't look at the 3 just yet. You just hear what's the derivative of cosine? It's negative sine, right? So then we put the 3 here of 2x squared. The whole this is the inside, right? And then take the derivative of 2x squared. Okay. So then this becomes negative 3 sine 2x squared times 4x. And then here we'll just put this over here. So this is negative 12x times sine of 2x squared. And this is dy dx. dy. Okay. You see, these are getting fun, right? Who's having fun? All right. Let's keep going. Here, y is equal to 3 sine. All right, so here, this is our outside. This is our inside. Okay. These two aren't that bad, right? These are pretty straightforward. So here, dy dx is equal to, so 3 cosine 2 minus 3x cubed times the derivative of 2 minus 3x cubed. Okay, my bad. Yeah, right? Okay, so now here, this becomes dy dx equals 3 cosine 2 minus 3x cubed times the derivative of this will be negative 9x squared. So then put this one over here, so this becomes negative 27x squared cosine 2 minus 3x cubed. And that is your dy dx. Okay, okay. I could tell you guys are getting into a good rhythm. Very nice, very nice. Okay. These were not too bad, right? Like, I think surprisingly, I think these two were a little bit easier than these two. Learning this new trick is nice, right? Okay, here, things get a little more tricky. Ay, pero mister, we got the square root on the inside and all that stuff. All right, so let's look at this one. Here, we have y is equal to 3 sine of 2 radical x. So don't freak out, set it up, right? So set it up. So this is y equals, okay, so then what's the setup? This is our outside, and this is our inside, okay? I want you to try this by yourself, right? You could do this, all right? So here, dy dx equals, all right, the derivative of 3 sine is 3 cosine, 2 radical x, and now we need to take the derivative of 2 radical x, right? Oh, you know who I'm going to give a shout out to? This is a shout out to Amanda Nazar. And why am I giving her a shout out? Because she says, Mister, I always skip this step. Well, good luck skipping this step without actually doing the work. Ha ha ha. Right? So here, what is the derivative of 2 radical x, right? Okay, what I want you to do is, maybe on a sticky note or whatever, try and do it on your own, on the side, right? So if I have 2 radical x, how do I take the derivative of that, right? We've done this before. Notice that 2 radical x is the same as 2 times x to the 1/2. Now, you use the power rule. How do you use the power rule? Now, this is a half times 2, right? A half times 2 times x to the 1/2 minus 1. Okay, if I did that very fast, pause the video and rewind, right? What are you doing? A half times 2. So this really just becomes 1x, right? Or just x, okay? And then what's a half minus 1? By now we should be okay with this, that a half minus 1 is the same as a half minus 2 over 2, which is negative a half. So this just becomes x to the negative half. Did you do that fast, Amanda Nazar? I don't think so. Maybe in the future, yes, but okay. So here, this is x to the negative 1 half, right? And then also remember that what is x to the negative 1 half? We could simplify this a little more. This could be 1 over x to the 1 half, which is equal to 1 over the square root of x. Okay? So that is this. This basically, the derivative of 2 radical x is 1 over square root x. Okay? Did I block that off? I'm sorry, I did, but here. Okay, so then now here, let's go back to the problem. So this is 3 cosine 2 radical x times this. But then that's 3 cosine 2 radical x times 1 over square root of x. Okay? And now here, this is dy dx, right? Dy dx. Now here, the idea is you just have this. You have, remember that this is over 1. So this is 3 cosine 2 radical x over square root x. Okay? And this is it. That was a lot of work. Well, not a lot, but you had to put in some work over here. Like, notice that where was the most amount of work was taking the derivative of this, right? To do this part for the chain rule, that wasn't too bad, right? What I want you to do is try and do this one all by yourself, okay? So let's see. Looking at let's have the other one right next to us, just so we could see step by step. So here, notice that this is y equals, okay, so then what is our outside? 2 cosine, and then this is 3 square root of x. Okay. So now dy dx is equal to 2 times negative sine of 3 radical x. And now you got to take the derivative of 3 radical x. Okay? So what I want you to do on the side, the same way we took the derivative of 2 radical x, pause the video and try and find the derivative of 3 radical x. Okay? So if you want to see how it's done, how do you take the derivative of 3 radical x? Notice that that's 3 times x to the 1 half. And now here, power rule, this becomes, what's 3 times a half, right? That's 3 over 2 x to the negative 1 half. But then what does this become? This is 3 over 2 times 1 over x to the 1 half. But then that becomes 3 over 2 square root x. Okay? You gotta, this is it, right? We've done this before. Okay, so then this goes here. So then this is 3 over 2 square root x times, okay, now we bring this down, 2 times negative sine 3 radical x. Okay, so this is dy dx. Okie dokie. So then what happens? This is, let's see over here. So then we put this over 1. So then dy dx is equal to, notice that the top becomes negative, notice here that because we have this 2 and this 2 here, this becomes, this cancels out and this cancels out. Okay, because if I have a 2 on the top and 2 on the bottom, they cancel out. So I'm just left with negative 3 sine 3 square root x over square root x. And then this is it. Okay? Alright. Now for this part over here, it's really not too bad. I'm going to leave it up to you and I want you to try and figure it out yourself. The hint I'm going to give you is, the way you first set this one up is, you say, okay, well notice that y is equal to 2 times sine of x. Pause the video. What do you think we're going to have here for an exponent? half. So then now here, y equals, okay, now what is our outside? What is our inside? This is 2. And what's our inside? Sine of x. Okay? Because the bell's about to ring, I don't have time to finish it up for 7 and 8. But try and do 7 and 8 on your own, and I'll put up the solution in class for you to see. Proud of you. Good job.